Alrighty, so we're at 3.6 standard form. This is really the tail end of this rather short unit, but it is definitely something where it's the starting point for the next unit. So a nice little bridge, and we're talking about standard form. So any quadratic, we truly, honestly, we're assuming that if it's not in vertex form, it's not in intercept form. This is usually where we're starting with this. So in terms of standard form, y is equal to ax squared plus bx plus c. We like this one the best. If we're interested in that starting location, that initial height, where we're talking about the y-intercept. So standard form, we're super interested here with the constant in the situation, which is the y-intercept. This is the most used form, as previously mentioned, of a quadratic function. It's compared to intercept form and vertex form, and every single problem that we do in the next unit is going to start looking like this, so get used to it. So standard form again, y is equal to ax squared plus bx plus c. I know that comes in a couple different, with a couple different terms. We know we're pretty much guaranteed this quadratic term. If there wasn't a quadratic term, it wouldn't be a quadratic. That kind of makes sense. So we're always going to have that quadratic term. The other two potential terms we could have is that bx, which is the linear term, and of course, as previously mentioned from before, we have c, which is the constant term, also known as the y-intercept. The other new thing for this scenario is that outside of the y-intercept, a lot of this is kind of sort of, to a certain extent, plug and chug in terms of finding points, but we do have an axis of symmetry formula. So this axis of symmetry formula, which I don't necessarily like the way that it's typed up here, so I will write it out on this as well, just so we're aware of what it looks like. It is a fraction. That fraction is negative b divided by 2a. And of course, what we're referencing here is the b in the a up in standard forms. Those would be our coefficients, b being the coefficient for the linear term, a being the coefficient for the quadratic term. And that's going to calculate axis of symmetry. That's going to calculate, again, we know that right there is our mirror. So there is kind of sort of a lot of work here to get to that mirror. But once I have that mirror, I can take that h and plug it back in to calculate the y value for the vertex. So once I have the axis of symmetry, I can plug it into the standard form to figure out the y for the vertex. All right, so a little bit of practice here in terms of this. Let's go ahead and take a look at these quadratic term, linear term, constant term, just picking it out. Again, the quadratic term we've talked about is that term that has the exponent of 2. So the quadratic term here would be x squared, x squared, x squared, and oh, look, be careful now. It's the term with the variable exponent of 2. We'll go ahead and say 1/4 x squared is our quadratic term. So we like to have it in descending order with the biggest exponent on the left. Sometimes it doesn't happen. Negative 1/4 x squared is our quadratic term in this scenario. The linear term, this would be the one that has just the variable x, so I'm looking at 2x, I'm looking at negative 8x, oh, there's nothing here for this one, but we can go ahead and consider that the linear term would be 0, because 0 times anything, in this case, the linear term would be 0x. That's important to kind of sort of conceptualize there, that there is a 0 for the b value, especially if I need to go find the axis symmetry. And then finally, the linear term is a 2x in the last one right there. Finally, the constant term. The constant term, of course, is just the number. There's no variable. I don't see one in the second one, and of course, we would love to have a placeholder. We know that that constant term would be 0. -6 right here, and then again a 0 for that last one as well. So just understanding that in terms of points, 0, -6 would be our y-intercept for 2 of these, and for 2 of these our y-intercept, and technically our x-intercept as well, would be 0, 0 on that. We're going to pause there. We're going to go ahead and reset in terms of how we're going to graph these things in a moment.